Alright, 5.4, Derivatives of Trigonometric Functions. What we're looking at here, folks, is being able to find the derivatives of sine x, sine of a function, and cosine of a function. The derivatives of these are very simple. The derivative of sine is cosine. The derivative of cosine is negative sine. Now, if you want to remember it, we have to remember that if you have a function in the front, you need to take the derivative of that function and multiply the derivative of sine of that function. So in this case, the derivative of sine is cosine. Derivative of the function, so f prime of x, times cosine of f at x. The derivative of cosine of a function is equal to the negative of the derivative of sine of the function. All right, now, you have to remember the different identities. So I'm just recapping all the identities we've learned thus far. There's the Pythagorean identity, which is sine squared plus cos squared equals 1. The quotient identity, which is tan x is equal to sine x over cos x. And finally, there's the reciprocal identity, which is cosecant x is equal to 1 over sine x, secant x, which is 1 over cos x, and cotangent x, which is 1 over tan x. The reason we need all these is the fact that you may have to simplify an expression before you take the derivative, or you might have to, after you've taken the derivative, you might have to simplify the function before you find the max or min values. Then moving on. The other rule that we have to remember is the compound angle formula, or the double angle formula. Now, most of the time when I teach students, I talk to them about just learning the compound angle formula. The reason you want to learn the compound angle formula is because the double angle formula is actually derived from the compound angle formula. For example, sine x plus y, or sine x minus y, is equal to sine x cos y plus or minus sine y cos x. Now, for the double angle formula, we're talking about sine 2x. What would we do with 2x? Well, 2x can be rewritten as sine of x plus x. Well, how does that help us? Well, we can use the compound angle formula to find the simplification of the double angle formula. Sine x plus x is equal to sine x cos x plus sine x cos x, which simplified will equal 2 sine x cos x. Now, cos of x plus or minus y is equal to cos x cos y minus or plus. Now note, if it's plus here, it'll be minus over here. So it'll be the opposite sign. Kind of like you think of the derivative of cosine has the opposite sign. Where sine has the same sign, cosine has the opposite sign. So cos x cos y minus or plus sine x sine y. How does that help us with the double angle? Well, cosine of 2x is equal to cosine of x plus x, which will result in cosine of x cosine of x minus sine of x, which will result in the simplified answer of cos squared x minus sine squared x. So, just to recap, CAF rule is the most important rule. So these purple rules here are the most important rules for you to remember. Everything else, I don't worry about. All right, next. Example number 1. Determine dy by dx. Y equals sine 3x. We need to find the derivative. Sorry, folks. Dy by dx is equal to, this one's easy, 3 cos 3x. Let's look at the next one. Y is equal to x squared sine x. What are we going to do with this function? Well, folks, we need to perform the product rule. Dy by dx is equal to 2x sine x plus x squared times cos x. From that, we'll common factor because that's what we naturally tend to do. And we get x times 2 sine x plus x cos x. C, y equals e sine x plus 2 cos x. E to the sine x plus 2 cos x. The derivative of e is equal to e to the same number times the derivative of the exponent. So the derivative of the exponent is going to be cos x minus 2 sine x times e to the sine x plus 2 cos x. And that would be the derivative. All right, let's move on. Next, example number 2. Determine when dy by dx is equal to 0 if y equals cos cubed of 2x, when x belongs to 0 and 2 pi. So those are your closed domain. The domain can only go from 0 to 2 pi for x. So we now need to take the derivative. Before we do that, let's rewrite y as a something where we have a function raised to a power. That's what cos cubed 2x means. Well, here we can use the chain rule. 3 times the derivative of the inside, which is negative 2 sine 2x, times the inside squared. What does that give us? Well, folks, we can rearrange this so that we have important pieces isolated. Let me show you. When we set the derivative equal to 0, we get negative 3 cos 2x times 2 sine 2x cos 2x. Why did I do that? Well, within here, I can see a double angle formula showing up. There's a 2, a sine 2x, cos 2x. That's exactly what's going on here. In there, there's a double angle formula. 2 sine 2x cos 2x is equal to sine 4x using the double angle formula. How does that help us? Well, looking at this question, we would have to find the derivative of both cos and sine. Here, we also have to find, not the derivative, but when cos and sine equals 0, but at a much more simplified value. Either way, whether we use this value, these values, or these values, we will get the same answer. That I can promise. All right, so 0 is equal to negative 3 cos 2x sine 4x. Cos 2x equals 0 and sine 4x equals 0 are the values that we're looking for. What that will give us is all the possible values, which are, now, for the cosine is equal to 0 at this point and at this point, which means that 2x is equal to pi over 2 and 3 pi over 2. Problem is once I divide by 2, it means there are more values that must be there. So what we would do is continue this cosine loop until we reach beyond the original domain that you were restricted. So think of it as we are dividing all of these numbers by 2. So this will be pi over 4, 3 pi over 4. What's the pattern going on here? Well, it's 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and then 9 pi over 2 I'm going to put in red, just to see that that one will not fit. When I divide by 2, what will happen is that I get pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and the last one, which is 9 pi over 4. 9 pi over 4 is beyond the restricted domain, so therefore 9 pi over 2 is not the one that we need. Do the same for sine. Sine has the values of 0, pi, and 2 pi. What values will give us the value of 0 for sine 4x equals 0? Well, folks, that will be 4x is equal to 0, pi, 2 pi, keep going, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and 8 pi, so that we have all of these values here. If you look very carefully, some of these values are actually repeated. For example, here, pi over 4 is the same here. So this is the same here and here. So you do not need to repeat them. So this does not need to be repeated. So we can cross that one out. Then the next one, 3 pi over 4 is here, which is here as well. Cross that one out. 5 pi over 4 is here, which is repeated here. So we can cross that one out. And finally, 7 pi over 4, which is here, and we can cross that one out as well. So that those values are all listed down here. This is how many values we have. We have 4, 5, 6, 7, 8, 4, 8, 9 values to give us when this function is equal to 0. So when the derivative is equal to 0. All right, let's move on to the next one. Example number 3. Actually, before I forget, I'm going to give you the example. Then what I want you to do is try to answer the questions in this video. And move on to the second video once you've found the solution. All right, see you in the next video.